mistake that students make, and I make myself as well. So let's go ahead and look at this expression here. Inside the parentheses we have x squared plus y, and that's all being raised to the second power. So it is very wrong to go ahead and distribute this 2 into the, let me go ahead and put an exponent on this y. So what I'm doing right now is the wrong thing. You should never do this. You can't treat this like the power rule and just go ahead and multiply these exponents here. So 2 times 2, get 4 out of that, plus 1 times 2, get 2 out of that. This is very wrong, what I just did. The reason we can't do this is because this addition here is ruining it for us. And going back to what exponents really mean, what this 2 is indicating for us is that we have 2 of these, right? That's what the exponent always represents, letting me know how many of that I have. So really what this is saying is I have x squared plus y, and then I have another x squared plus y. This is really what this is what this is really saying. And then we would go ahead. I can't speak today. So we would go ahead and have to FOIL this out to get the correct answer out of it. But really quick, if you wanted to get the correct answer out of this, we would FOIL this out really quick. So we would get x to the 4th plus x squared y plus another x squared y plus y squared. And then these like terms here we could combine, so we get x to the 4th plus 2 of those x squared y's plus y squared. So this right here should be the correct answer. Notice how much different this is from this. Yeah, so I just wanted to point that out. It's just a common mistake that comes about, so be careful with that. Okay, so moving on to our next law, we're going to look at the zero power law. It's a pretty straightforward law. I would say it's the easiest one out of all them. So let's say you had something raised to the 0 power. So let's say I had 4 raised to the 0 power. And let's go ahead and look at a variable while we're at it. So let's say we had x to the 0 power. So it turns out that if you raise anything to the 0 power, the answer turns out to be 1. So this is going to be 1. X to the 0 power, that's going to be 1. This is a debatable one when you have 0 to the 0 power. Many people say that that's not defined, and others say that's still 1. But in our case, whenever we see something raised to a 0 power, we're just always going to assume that that's 1. So let me go ahead and start by starting with 3 and cubing it. Then let me take that same 3 and then square it. Take that 3, raise it to the first power, and then all the way down to the 0 power. So let's go ahead and investigate to see what happens here. So 3 cubed, that would be 27. 3 squared, that would be 9. 3 to the first power would be 3. And then this is what we're trying to experiment on to see how, to see if we get 1. What we do. So notice that to get from to a lower power, what you're really doing is dividing by 3 every time. So 27 divided by 3 would be 9. And then 9 divided by 3 would be 3. So notice you're just dividing by 3 every time. So the next step here would be to divide by 3 again. So 3 divided by 3 would be 1 again. So I don't know if that was the best explanation, but it gives you a little intuition on why when you raise something to the 0 power, the answer turns out to be 1. Okay, so we're going to move on to our next law now, which is the negative power. So let's go ahead and see what that would look like. So negative power is just really what it's saying. It's just when you have a power that's negative, like for example, x to the negative 2. So the way you go about this law is that, so you know, we could look at this as a fraction, because there's a 1 under everything, right? So really, the way I like to think about it is if you have a negative exponent, then your base, So here, this is our base, the x is our base, and the negative 2 is our exponent. So when we have a negative exponent, the way I like to think about it is that our base is sitting on the wrong side of the fraction bar. Because the fraction bar, there's a top and a bottom to it, there's the numerator and the denominator. So since I have a negative exponent right now, this x shouldn't be sitting in the numerator, it should be sitting in the denominator. So what I'm trying to say is that, when it is sitting in the right place, you change the negative exponent to a positive exponent. So this x to the negative 2 power, the negative exponent indicates that this x should actually be on the bottom with that same power but positive. And then since we suck this x to the negative 2 down on the bottom, we can't just leave the top blank. So we have to put a 1 there to account for that. But really, when they teach you the exponent laws, for example, this is the same thing, x to the negative 2, they just say it's 1 over that. It's just 1 over what you had to a positive power. But the way I like to think about it is that your base is actually sitting on the wrong side of the fraction bar. So if you want to look at another example, let's say we had this example here, 1 divided by x to the negative 4. Again, notice we have a negative exponent, so that's like alerting off in my mind is that this base is actually sitting on the wrong side of the fraction bar. It should actually be sitting on top, but with the positive exponent. So I'm going to bring this guy on top. And then you don't have to put the 1. That 1 is unnecessary. You do have to put the 1 like in the previous example. But in this case, the 1 is not necessary. So I'm just going to leave it as it is. But yeah, that's pretty much the negative power law. You could bring the base up and down, but with the positive exponent. Okay, so still on the negative power law, let's go ahead and look at another example here. Again, it's another one of those things that students and myself tend to mix up sometimes, so you want to be careful on this. Notice that the only thing that has a negative exponent right now is the variable x. This 3 is not being raised to a negative exponent. So when we're doing this negative exponent law, you only want to apply it to what has a negative exponent. So this 3 doesn't have the negative exponent. I don't know why I keep saying that. So really my focus is on this guy right here. And then just getting messy all over the place. So you do not have to do this whole division bar thing. I'm just doing it for the lesson. So this x, since it has a negative exponent, it's actually sitting on the wrong side of the fraction bar. It should be on the bottom with a positive exponent. So this 3 is going to stay on top because it doesn't have a negative exponent. It's sitting where it should be. This x to the 5th is going to come down, but it's going to have a positive exponent, right? That's what we said the negative power law indicates. You just move what has the negative exponent to the other side of the fraction bar, but with the positive sign. And yeah. Okay, this is the last thing I'm going to do on the negative power law, negative exponents. So, and this is another reason to explain why anything to the 0 power is 1. So let's go ahead and apply the negative exponent law to this and see what happens. So notice that we have the same base here. So we could go about doing this with the product same base, which was the first rule we learned today. And that's when you just write the common base, the same base just once, and you add the exponent. So 1 minus 1 is 0. But I want to go ahead and apply the negative power law to this. So notice that this is the guy that has a negative exponent. So it's sitting on the wrong side of the fraction bar. If there was a fraction bar here, it should be sitting on the bottom. Right? So this x to the first power is going to stay on top, but this x to the negative power is going to come down on the bottom, but with a positive exponent, right? Applying the negative exponent, the negative power law to this guy. And then I don't really have to put these 1 exponents here. I think they're a bit distracting. So, and then we know that this will just cancel out, right? X divided by x is just 1. So this will reduce down to 1. And we know x to the 0 power is 1. Getting the same answer, going about it 2 different ways. And it's just another way to show you that, show you why when you raise something to the 0 power, the answer turns out to be 1. I'm just going to go ahead and apply everything we learned to some examples right now. I'm going to do a couple, and then later I'm going to have you guys try some. So let's go ahead and attack this problem right here. Since we're dealing with exponents, and these guys, I don't see any exponents up here, I'm just going to put the 1s there for myself to see what's going on. So it looks like what's happening here is I can't simplify anything inside the parentheses. So I'm going to go ahead and look at the overview. So looking at this guy here, it looks like it's a power to a power law, because these guys have powers, and they're being raised to another power. So I'm going to apply this power to each of these powers individually. So there's the 2, 1. So I'm going to multiply these powers together. 1 times 2 is going to be 2. And then we're going to multiply these powers together. So 1 times 2 is also 2. Okay. I could still keep this in a parenthesis if I'd like. So let's move on over here. Same thing here. It's a power to a power rule. So there's my 3, which is the base, multiplying the powers together. And then here's the x, multiplying these powers together. These parentheses are unnecessary, but you could keep them like that if you'd like. So let's go ahead and simplify some more. 2 squared would be 4, so that's 4x squared. Again, you could keep it in the parentheses still if you'd like. 3 cubed is 27. X cubed. And then, so what we're going to have to do now is multiply. So 27 times 4, let's see, 7 times 4 is 28. The 2 would come up, so 4 times 2 is 8, plus the 2, that would be 108. So that's 4 times the 27. And then notice here there's a product happening with the same base. So this is the first law we learned, which was the product with the same base. And what that tells us to do is write the base just once and add the exponent. So 3 plus 2 is 5. I hope I didn't talk too much, but that's how you would go about doing something like this.